Good morning. Myself, Prabharanjay, working as an assistant professor in ECE department at SNS College of Technology. In this lecture video, I am going to discuss about the topic is timing issues from the unit 3, that is sequential logic circuit in VLSI design. Let I discuss. Okay. Synchronous timing. It is a design methodology where the operation of digital circuits is coordinated by a global clock signal. That means common clock signal. All parts of the circuit execute their operations in synchrony with this clock signal, which help ensure predictable and reliable timing. The clock defines specific time interval, that is clock cycle, periodic cycle, and all changes in the state of the system occurs at well-defined times. Here we will discuss the some of the topics, that is clock signal. What is mean by clock signal? A periodic signal that oscillate between high, that means logic 1, and low, that is logic 0 state, synchronizes operations across different part of the circuit by dictating when data is captured and processed. Circuit rely on clock edges, that is rising edge and falling edge, to determine when to trigger transition. And another one is clock period and frequency. Clock period, the time between two consecutive rising edges of clock signal. Clock frequency, the inverse of the clock period. It dictates how fast the circuit operate. And another one is setup time and hold time. The minimum amount of time before the clock edge, that the input signal must be stable and valid to the correctly latched by a flip flop or latch. Hold time means the minimum amount of time after the clock edge that the signal, that the input signal must remain stable to ensure proper latching. Next one is clock skew. The clock skew, the difference in arrival time of the clock signal at different part of the circuit. Skew can be positive or negative and must be minimized to ensure correct timing. Clock skew can result in setup or hold time violation if it becomes too large. And another one is clock jitter. Yeah. Clock jitter is the variation in the clock signal period or phase from its ideal value. It can be caused by noise in the clock generation of distribution circuit, power supply fluctuation, or environmental factor. Okay. Latch parameters. Delays can be different for rising and falling data transition. Here you can see the rising and falling data transition. And register parameter, here D flip-flop register. We are using D flip-flop register. Delays can be different for rising and falling data transition. You can see in this diagram. Already we have discussed what is meant by clock skew, what is meant by clock jitter. Okay. And shortest path. Worst case is when receiving edge arrives late race between data and clock. You can see earliest point of the latching and nominal clock edge, and data must not arrive before this time. Okay. Next one is latch timing. Uh, Latch is a soft barrier when data arrives to transparent latch. Okay. Um, then propagation delay. Okay. Addressing these time issues is crucial in modern VLSI design, especially as technology nodes shrink and clock frequencies increase. If you have any doubt, you can comment me through the comment. We will meet in next video. Thank you.